Good afternoon, boys and girls. This is Miss Suzanne teaching you how to use manipulatives in finding out the area of two distinct shapes. Last week we used algebra tiles to figure out algebraic expressions and how to solve those. So I have what you can do is you can either get a pegboard or you can draw out your shape on a piece of graph paper. So today I have it drawn out on my pegboard, and I'm going to use algebra tiles, so the 1 unit algebra tiles, to fill in the shape. And then I will show you a way to figure that out using a different method in just a moment. So yeah, this takes a little bit of time, but you can see where I'm going here. Okay, in a normal algebraic expression, you have a square that is 2 centimeters on one side, and it is a perfect square. And we know this because all 4 sides are equal. So you have a 2 centimeter square that you need to find the area of. You take one side and you times it by 4. So one side is 2 centimeters and you times that by 4 because it's 4 equal sides, and you have a 8 centimeter squared area of a shape. However, in this example, you have three tiles by 3 tiles by 3 tiles by 3 tiles. That doesn't exactly equal 12 because we are using the algebra tiles to find out how many algebra tiles filled in this square. So you've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. So in this square, 9 algebra tiles filled in the square. So your area of this square is 9 units. Okay. In this shape, which is a chair, you have 1, 2, 3, 4, 5, and 6. That is the area of this shape, which is a chair. A very blocky chair. So the next 2 examples are on this pegboard. This is a buildable pegboard. So these pegs are not permanently in place. Normal pegboards, they are permanently in place for the most part. And what I've done is I've built my shape and I've placed a spacer of 1 circle in between my 2 tines. If I didn't do that, say I put this tine over here, which would cut this in half, and then took out this tine and placed this in the middle here, this would also cut it in half. I would not have the same area as I do here. By doing it every other one, I have the same area. So you'll count. So the tines are put together by rubber bands or held in place by rubber bands, and they each create their own little square. So 1, 2, 3, 4, 5, 6, 7, 8, 9. If I didn't do it by every other one and I just split my square in half, I would only have 1, 2, 3, 4 squares. So you have to be consistent when you're trying to figure out the area of a shape using any form of a manipulative, whether it be tines, algebra tiles, rubber bands. This shape is the exact same shape. Once again, every other hole is left open. And this is also 1, 2, 3, 4, 5, and 6. So you'll count the squares that make the shape. Okay. Hopefully this makes sense. If you have any questions, please feel free to reach out to me, and I will answer them in the order that they were received. Have a good day, guys.